Hey everybody, this is a challenge from picoCTF 2024. This is a reverse engineering uh, challenge. I've kind of been in doing a lot of reverse engineering videos because I'm getting into it. I'm also trying to learn myself. So this is a medium one. They provide you with a bin file. So let's go ahead and analyze this. So if we do file bin, we see it's an ELF64 bit, right? And if we do strings on the bin, we have a bunch of stuff here, nothing really too interesting, except there is part of a flag here, which is helpful. So let's actually take this down. We're going to copy that and let's have this for our use. And yeah, so we're going to actually open up Ghidra and see if we can pick this apart. I would use IDA, but this is an ELF file, so I find it easier to use Ghidra for this. So let's open bin. Yes, and we're going to analyze. Okay. So it looks like we're in the main function right now. We can see that there's a bunch of allocation of variables here, and here's our string that we found. So that's interesting. This is a bunch of allocating variables to, it looks like some numbers here, some strings. If we go down, we're going to find some conditional statements here. So let's actually start with the first one here. If you notice, there is a concatenation here. We're appending something to a string, right? We're appending C8 to 248. Now, what is 248? That is our string. So we probably need to go through these to figure out what the flag is. So it looks like we're assigning PCVAR2 to a string located in 208. So if we find the references to 208, I forgot, that's not going to do. So if we go to 208, we go here and we see where the data is. We see that that's a 5. So now that we know it's a 5, it's trying to say if the data at PCVAR2, which is 5, so it's a pointer to 5, is less than B, then we append C8. So we can actually check this with Python. We can say the ordinal, so ordinal at 5, remember it's a string, is less than the ordinal of B, and we see that that's true. So this is going to execute this statement, and it's going to add C8 to our flag. So what's in C8? C8 is a 9. Okay, so let's add a 9 to our flag. And following along with the logic here, we have a PCVAR2 assigning to local A8, and A8 is where's A8? I don't see it. Local A8, right? Local A8. I don't Oh, it's right there. Okay, sorry. That's a 6. Okay, and so it's checking to see if 6 is not equal to A, which is going to be true. So ordinal 6 not equal to ordinal A. We see that that is true. So this is going to execute. It's going to add local 68 to our flag. So 68 is right here. And that is a 7. So we're going to add 7 here. Okay, and now if we go down, we see PCVAR2 being assigned to local 1C8. Okay, so local 1C8. 1C8 is a 3, so let's make a note of this. Let's say PCVAR2 is equal to 3, right? And then we're saying CVAR1 is equal to the data at PCVAR2 currently. So that's basically just 3. So CVAR1 is equal to 3, right? Now we're reassigning PCVAR2 to local 148, which is going to be E. Okay. So now PCVAR2 is equal to E. Okay. Now you have to pay attention here. It's saying that the integer of CVAR1, which as we know is still 3, and we're subtracting that from the current pointer of PCVAR2, which is going to be E equals 3. So let's actually see if that equals 3. So we can say, let's be very explicit with this so that we can make sure we're doing this correctly. Integer of CVAR1, which is going to be 3. So take that minus integer at, we're going to have to do ordinal because it's a character, it's a car. So PCVAR2, the pointer currently at PCVAR2, which is going to be E. So E. If that equals 3, that's going to be false. So that is not going to execute. Okay. Now there's no if condition, we're just adding stuff on. So 1E8 is 1E8. That is a 7. So we're adding a 7 here. And then we're adding a 188. So 188 is going to be here, which is a 5. Okay. Now we're going back down. We have one more conditional statement here. We're saying PCVAR2 is equal to 168. So let's go to local 168. And we see that that is A. So we have A. And it's checking to see if that is equal to G, which we know lowercase car A does not equal uppercase car G, so that's going to be false. That's not going to execute. And now we're doing some final concatenation here. So we're adding 1A8. So what is 1A8? 1A8. We see that that is 0. And then we're adding local 88. So local 88. Here it is. That is D. And then we're adding 228. So let's find 228. 228 is right here. And we see that that is a 5. And then if we go back down, we see 128. So we're adding 128. Local 128, which is right here. And we see that that is an F. We have an F. And then what we're going to do is finally we have our closing bracket, which tells us that that is all there is to the flag. So now we'll just add a closing bracket, and that's our flag. Let me see if I can put this in, even though I've already solved it. It should be that. Submit flag. Solve the sharing correctly again. Okay, yeah. So there you go. That was kind of fun. This was more of a fun sort of a scavenger hunt, reverse engineering. And yeah, there you go.